So here is 6th number. An aircraft is flying horizontally with constant velocity of 400 meters per second at a height 2 km above the ground. At the same moment, a bomb is released from the aircraft, and at same instant, a cannon gun on the ground fires a shell with initial velocity of 400 meters per second at an angle theta. The cannon gun is at horizontal distance of 2 under root 3 km away from the aircraft as shown in figure. If cannon gun just destroyed the bomb, then what should be the angle? Now let us consider the situation. Suppose they are meeting, since cannon gun has to destroy the bomb, so suppose they are meeting at this particular point. Both particles are meeting at this particular point. Coordinates are suppose x and y, means this is y and this one is x. Now let us calculate the vertical displacement first. So for bomb dropped from the plane, we have displacement covered, vertical will be what? 2 km minus y, that is 2000 minus y. So we can write 2000 minus y equals, bomb is projected horizontally, so vertical component has 0 initial velocity, so half gt square. Half gt square. They are meeting at time t. Now this is for bomb. Now for cannon, we have vertical displacement given y equals, horizontal velocity is 400 cos theta, initial vertical velocity 400 sin theta for cannon. So y will be 400 sin theta t minus half gt square. Now adding these two equations, we get 2000, y will be cancelled out, then 2000 will be 400 into sin theta into t, or we get t sin theta equals 5. Let us take it as equation number 1. Now vertical displacement has been discussed. Now let us focus upon horizontal displacements. So for bomb from the plane, horizontal distance x will be covered by horizontal velocity, that is 400 times t. And for cannon, horizontal distance, that is 2000 under root 3 minus x, will be covered by horizontal velocity, that is 400 cos theta into t. Now solving these two, this equation and this equation, will get the value 400 into t 1 plus cos theta equals 2000 under root 3, and after solving we'll get the value, that is t into 1 plus cos theta as 5 root 3. 400 will be cancelled with 5 times, so 5 under root 3. This we will get. Let us take it as equation number 2. Now we are having two equations, t sin theta equals 5 and t into 1 plus cos theta equals 5 root 3. Dividing 1 and 2, what we are going to get? T cancel out, so left hand side sin theta upon 1 plus cos theta, right hand side 1 upon root 3. Let us cross multiply it and see what we are going to get. Root 3 sin theta minus cos theta equals 1. This is what we will get. Let us divide with 2 both sides. We'll get root 3 by 2 sin theta minus 1 by 2 cos theta equals 1 by 2. Now this can be arranged or rearranged in form of some trigonometrical identity, that is sin theta cos 30, cos theta sin 30. So root 3 by 2. Let us rearrange it. Sin theta root 3 by 2 cos 30 minus cos theta 1 by 2 sin 30 equals 1 by 2. Sin theta cos 30. Sin theta cos 30 means sin A cos B minus cos A sin B. This is the formula for sin A minus B, where A is theta, B is 30 degree. So we'll get sin theta minus 30 as 1 by 2 is what? Sin 30. Now equating the angles, we will get theta minus 30 equals 30. Therefore theta will be 60 degree. So if the cannon is projected with an angle 60 degree, then surely it will hit the bomb. So we'll go with option number 2, which is absolutely correct. Now move on to the next, that is 7 number. So here is question number 7, everyone. The top view of a system as shown in figure, in which 3 persons tried to displace the block placed on the smooth floor. Mass of block is 40 kg, F1 60, F2 50 and F3 25 under root 2 Newton. Then the magnitude of acceleration of the block will be what? Forces are acting in the horizontal plane. So block will also accelerate in the horizontal plane. Weight of the block will be cancelled by the normal reaction. We have not to consider weight of the block as well as normal reaction in the net force. Now let us take the y component of all these forces one by one, and before that let us draw an equivalent diagram for the forces. F2, that is 50 Newton, acting 37 degree. So this is F2 50 Newton. F1 60 Newton, positive y direction. So that is F1 60 Newton in this direction. This angle is 37 given. And one more is F3 45 degree, but in this direction. So F3 how much? 25 under root 2 at an angle 45 degree. So you can take this angle as 45 degree. So this is equivalent diagram, and here is the block, 40 kg block. Total y component of forces Fy can be given as 60 plus 50 sin 37 minus 25 root 2 sin 45. Solving gets you total value of Fy as 65 Newton. Equation number 1. Similarly, let's do the same for Fx. The total forces in x direction will be given by 50 cos 37 plus 60 is purely in y direction, it has no component in x direction, 0, plus 25 root 2 cos 45. After solving gets you Fx as 65 Newton. So both forces in y direction, 65 Newton are perpendicular. So the net force is given by 65 under root 2 Newton, and the acceleration will be net force, that is 65 under root 2 upon mass, that is 40. After solving, evaluating gets you 13 by 8 under root 2. This will be the acceleration of block. Now let us go for the option. We can say that option number 2 is absolutely correct, so we will go with option number 2 only. Now move on to the next, that is 8 number. So here is question number 8, everyone. A fixed U-shape smooth wire has semicircular bending between A and B shown in figure. The bead of mass m moving with uniform speed v through the wire enters the semicircular bend at A and lifts at capital B. The average force exerted by the bead on the part AB of the wire will be what? According to Newton's second law of motion, we know that the net force or average force given by rate of change of momentum with time. When the bead was reaching at A, the speed was mv left. At the instant of leaving, mv at right. So we can surely calculate the change in momentum, that is final mv minus initial mv. In left, that's why negative. So 2 mv change in momentum. what time it took, we can calculate delta T. Semicircular wire, so time will be what? Half of one cycle, that is pi r divided by V. So the net force we can calculate 2 mv divided by pi r divided by V. Solving it gets you 2 mv square upon pi r. 2 mv square upon pi r. Option number 1 is perfectly matching, so I'll go with option number 1 only. Move on to the next, that is 9 number. So here is question number 9, everyone. A block of mass 20 kg is resting on a rough horizontal plane of inclination 45 degree as shown in figure. The block is tied with horizontal string which has a tension of 100 Newton. The minimum value of coefficient of friction between the contact surface is what? Now block has to be at rest and we have to calculate the minimum value of friction. Let us identify the forces. Weight mg in this direction, component of mg, that is mg sine 45, here will be mg cos 45, contact reaction, that is normal reaction, and in this direction block has tendency to move down the plane and surface is rough, so friction will be in this direction, suppose Fs. Tension in the string is also T, which is given 100. Now break the component of T as well. This angle will also be 45 degree, so this component you will find T cos 45, and another component in this direction you will find T sin 45. Since the block is at rest, it means the net force down the plane must always be less than the maximum value of friction. So we can write FL must always be greater than friction force, or you can say stopping force must be greater than the net acting force, that is mg sine 45 minus T cos 45 up the plane, so T cos 45 degree. Now let us solve. FL, limiting value of the friction, is given by mu into normal reaction greater than mg sine 45 minus T cos 45. T is 100 upon root 2. Now solving it, we get mu into n, that is mg cos 45 plus T sin 45. So mg cos 45 upon root 2 plus T sin 45 upon root 2 greater or equal to mg minus 100 upon root 2. So mg mass is 20, g 100. So now we can calculate here mu. Mass is 20, g is 10. So we can write 200 upon root 2 plus T is 100, 300 upon root 2 this side greater or equal to 200 upon root 2 minus 100 upon root 2, that is 100 upon root 2 this side. Root 2 cancel out. We get the value of mu, that is greater or equal to 100 upon 300, that is 1 by 3. So in order to make the block at rest, mu must be greater or equal to 1 by 3, and we have to calculate the minimum value. So minimum is 1 by 3. So mu minimum therefore 1 by 3, and we'll go with option number 2, which is absolutely correct. Now move on to the next, that is 10th. So here is question number 10, everyone. Two blocks are connected by an ideal long string passing over an ideal fixed pulley as shown in figure. If the system is released from the rest, then the common speed v of the block when they moved a distance of 2 meter will be what? Given that m1 is 6 kg, m2 is 4 kg, and g we have to take 10 meter per second square. Now if m1 will move by a distance of 2 meter, the same way m2 will also move. It will also move by a distance of 2 meter, since they are connected through a string. Now let us apply the work energy theorem. when we apply the work energy theorem, work energy equation can be written as the total work done is change in kinetic energy. Total work done may be done by conservative force, work done may be done by non-conservative force, work done may be done by external force. So work done by conservative plus work done by non-conservative, there is no external force, so no need to write that term, equals change in kinetic energy. So initially means they were released from the rest, already mentioned in the question. So initial kinetic energy will be 0. We have only the final kinetic energy. Let the common velocity is v, so we can write the final kinetic energy half m1 plus m2 v square from here. Now conservative force, here for m2 work done is under the gravity, so conservative force work done m2g into displacement L, plus the surface is rough, mu clearly mentioned, so work done by friction, which is negative work done, that is minus friction force. We can write mu into m1g multiplied by displacement L equals half m1 plus m2 common speed v square. Now solving it, we'll get the value of v as under root of 2g capital L m2 minus mu m1 whole divided by m1 plus m2. So data is given in the question, so let's get the data from the question and plugging it in the final expression. We'll get the speed v as under root 2 into g10 L2 m2 4 minus mu 0.5 multiplied by 6, that is m1, divided by m1 plus m2, that is 6 plus 4. Solving it, we get the value of v as 2 meter per second. So the common speed after 2 meter of displacement can be given as 2 meter per second. Option number 1 is absolutely correct, so we'll proceed with option number 1 only. Move on to the next, that is 11 number.